Classroom. Okay, so today what we're going to do is go through optimizations. And of all the things I've gone over, optimizations are probably the one that's the most lucrative if you go into that field. What optimizations are is trying to find the best way to do stuff. And it could be delivering packages. It could be what we're going to do today is the best product mix. It could be how to do something the cheapest. There's all kinds of things you can optimize. But today we're going to go over how to optimize, and the one we're going to cover is profits. And optimizations are kind of they're tough for a number of reasons, and they really couldn't do optimizations until the Simplex method came along, and this was after World War II. And World War II actually was a big thing about optimizations, because it wasn't, you had to get you were fighting all around the world, and it wasn't just you had to get people there. You had to get people there. They had to be fed. They had to have fuel for the airplanes and and everything. They had to have ammunition. They had to have clothing. They had to have there's these huge lines of supply that go into that, and those are all optimizations. And there's untold times that something was lost because of something, they didn't get fuel to this place. They didn't get whatever it was. So that was kind of a real crunch to find some way to optimize something. And so that's when, this method came up. Is it just after World War II? I think it was like 1947, something, kind of ancient history. But it was still very cumbersome because, as you recall, they really didn't have computers or even really good calculators up until the 60s into the 70s, and certainly not the ones like we have now. So anyway, now setting up the problems is really the hard part. The optimization is actually the easier one. By the way, if you had your finite math class, you probably had this. It's probably the Simplex method. I don't know if any of you had that or not, but and I'll kind of go over a little bit of what it is. Hold on a second. Yeah. Let me switch cameras here. So here's what optimization is. It's kind of about. You're trying to optimize something, and usually for business, we're trying to optimize profits. And if you don't have any constraints, this will just go out to a bazillion. So they just sell 100 million cars. You can't do that, but that's what just do with their constraints. So what they've come up with is that there would actually be constraints on this, and everything has constraints. And the constraints might be labor. Today we only have 17 employees. Something like that. It could be space. We only have space to do, for 10 machines or whatever it is. And it could be materials. It could be all kinds of things. But the idea is that these are all constraints on us making our profit. Now, there's two ways to solve it. The two ways to solve it, there are two main ways to solve it. The one that we're going to do is the Simplex method, and there's actually a website that we'll go to that'll crunch out the numbers for us. Then there are, you can also do it in Excel. And the problem with Excel is it's fairly difficult to set up. So that's one reason why we're going to do it by using the Simplex method. Now, also, they may have fixed it in Excel, but one of the problems in Excel also is that sometimes you'll get the wrong answer, and I'll show you why that can occur occasionally. But the Simplex method is one that we're going to concentrate on. And those, if you haven't had finite math, this is a good website to know if you're going to, and I'll show you why in a minute here. But if you haven't had finite yet, this will be a good one to go over, and that you can actually go to the website and it can tell you how to solve these equations. But the Simplex method was the one that is probably the more accurate, at least right now, as far as finding these. And I'll kind of show you what that method is about. Let's see, switch cameras here. Okay. Here's what the Simplex method does. Oops. Microphone. Okay. Before the Simplex method, you would have to go through and try every single point on here. Now, we only have 3 constraints, but you could have 3,000 constraints. So you can imagine calculating where those 2 meet and then trying that, for every one of those. That would be no fun at all. So the Simplex method does 2 things. It'll tell you where to start. So it all starts here at 0, 0. And it says, okay, go this way. This way is better than that way. And just as important is that it tells you where to stop. Oops, I forgot it's supposed to stop. So it'll tell you where to stop. It'll say, okay, stop there. So it'll tell you where to start. We're directing to start, and then it'll say, okay, stop. Now, that might not seem like that big of a deal, but remember, if you got 3,000 of these things, and if you're doing these calculations by hand, telling you to stop, that's a good thing. It says, okay, don't go any further because it's not going to get any better than whatever it is here. So this would be the, the optimal place. And I made that look terrible. Okay, so this is what the Simplex method does, and this is in your finite class. They'll probably have you do this. You may have already done it. We do the shifting of the matrix. I don't know. Has anyone had that? Has anyone done that where it looks like this? Like if you have 2 variables, the x, y, have slack variables, and you have the different rows. And so, you don't have these? You do the pivoting? No,
it looked a little familiar. I think I did it a long time ago.
Yeah, it's doing the pivots and that in the calculator are no fun at all, and to some extent doing the going through the math part of it, you can kind of lose what's going on with it because the math part is kind of involved. Okay, so this is a Simplex method, and I'm just going to tell you about how the we're not going to do it, but I'm going to tell you how the Excel method works. Excel method works like this. So the Excel method says, okay, in the past, it would take a lot of time to do these calculations. But using Excel says, okay, well, we can make 1,000,000 guesses, and then look at that. I got something on me. I think I just drew on myself. All right. So so the Excel method will make they'll say, okay, that's better, that's better, that's better, that's better, that's better, and it'll zoom in on wherever the method is, but it'll make 1,000,000 guesses. Then say, okay, this one's the best. Whatever one came out here, okay, that one has, that's our answer. So a lot of times the Excel method, for simpler ones, it has no problem doing it. Sometimes what happens is it'll get caught up in one of these, and it'll go, okay, this is better, that's worse, that's better, and you can focus in on the wrong one. They may have changed it now. What is that gunk? Kind of like, I think I had a marker or something. Oh well. So anyway, the two different methods, and this is the one we're going to concentrate on just because A, I think it's more reliable, and B, this is what you'll probably see in your finite classes. So, all right, so let's go to the handout. Oh, wait, do I even have this thing up here? Okay. Okay, so this is the handout. Is there one that doesn't have it? If you don't have it, it's in Blackboard. Under the course files, it should also be in your email. Is there one that doesn't have it in their email? I can resend it if there is. Anyone that needs it? Okay, let me actually go here. So if you go to the website, there's also the link is here. It's an optimization website. And so this is the website we're going to be using to solve these. But before we do that, we have to be able to set them up. So here is, kind of, we have to set up these before. Once you get them set up, it's not too bad. Once we get them set up, it's not too bad, but setting them up can be a little bit tricky. And actually, that is the problem nowadays. The problem is in the calculations. The problem nowadays is setting them up. Okay, so let's take a look here. Okay, in business, I think I already mentioned it. In business, what do we want to maximize?
What was the question?
In business or in life, what do you want to maximize?
Profits.
Yeah, profits. So you only want to look at profits. It's not revenue, it's profits we're looking at, how much money you get to keep. So that's the same thing we're going to do here. We're going to optimize, and that's one of the things that makes business optimization is usually a little bit easier, because you're usually trying to optimize income or minimize cost. That's usually the two that you always see. So what we're going to do is set up this, so the setup is down here. So how much, let's take they make two types of stuffed cats. And here's the first one. How much are we making on each cat X?
$10.
Yep. And so that is the profit. It's nice about profit. Okay, so the profit would be that. And cat Y.
Same $10.
Yep. So you're just going to minus these. So we're making $10 on each of them. Oops. Now, we're not going to do anything with the fixed cost, and you'll recall why. In general, if the fixed costs don't change, they're not going to be relevant to a decision, at least not in the short term. So we're not going to really do anything with this. Not saying it doesn't exist. It does exist, but it's not going to matter for our decision making here. Okay. Now, if we just put this into our model, it would say make a bazillion cat X and a bazillion cat Y, because there's no constraints on it. You know, each one you make $10, make a 20 zillion of them. We know we can't do that. So coming down here, we have some constraints. So let's see here. Let's make this for cat X and for cat Y. So we're going to have some materials that are used, and we're going to have some sewing methods. So they sew these cats. They sew these cats together, and that's how many minutes they use. Now, there aren't just unlimited materials and unlimited minutes, so that's what we're coming down here to the bottom here. These are the constraints. So, oops. So when it comes to, say, feet of material used, wait, which one is first? Oh, it doesn't matter. Oh, I see. I'm sorry. Okay, so material used at 10 feet and 15 feet. Well, the most materials that they can get in and process is 1,800. So that is a constraint. And the sewing minutes used are the same thing. Let me try different. Hold on, let me. So the sewing minutes, it takes 6 minutes for cat X and cat Y takes 10. The most we can use is 2,200. Okay, so these are constraints. These are the most that we can do. So up here, this is kind of what we're trying to optimize. The profits, as much profit as we can. But here are the constraints. These are the things that are going to hold us back from making a bazillion of each. What we're going to try to do is optimizing it. In other words, making the most income that we can based on this stuff. And I think I'm going to kind of condense mine down so that it all fits on the same screen. I'm going to put these together. Okay. So the first one being up here. We're going to maximize. So we want profit. I'm going to make this in red. I don't know. So we're going to maximize our profit, and we want our profit to equal every cat X we're making $10 on. So I'm going to say 10X plus 10Y. So each one of those, you never use capitals, so they all look the same. Ooh, I'm not doing, hold on a second. Doing crazy stuff here. Okay, so this is what we're trying to maximize. So we want to make the most of those we can. You know, this will say, and again, if we don't have any constraints, it would just say, you know, make a bazillion of them. Okay, so let's go to the constraints. And the first one is materials. Okay, so let's take cat X. So cat X is using 12 feet of materials. So every cat X will use 12 feet of materials. Each cat Y will use 15. And I'm going to write something incorrectly here and see if, especially those of you who've had in a math, the most going to be is 1800. This actually isn't exactly true. Do we have to use 1800 feet of material? No, that's the maximum. So this is the most we can use. We could use less, 1500 or whatever it is. We could use less materials. So we don't have to use all of the materials. So this would actually look like this. This could be less than or equal to 1800. Okay, so this is what's on? Let's color that one. Okay, so there's one of our constraints. We can't just make as many of the, you know, a million of these. We only have 1800 feet of material. We don't have to use 1800 feet of material, but that's the most we have. Okay, next thing we're gonna do is the minutes. Oops. Next thing we're gonna do is turn off that stupid bold and highlight. Okay, minutes. And kind of the same thing. Now the minutes, each X takes 16. So this will be 16X. And cat Y takes 10. What am I doing here? Sorry. Less than or equal to 2200. And again, we don't have to use all 2200 minutes. So this would be the setup. we want to maximize this, subject to that. Now let's solve this one. Let's go ahead and solve this one. Let's go to the website. Let's see. So if you go to Blackboard, you can. There's also a link at the top of this thing. I'll go to that. And there's a bunch of notes here. We don't need notes. Maybe we do, but I'll take a look at this. So this will be how do I get to on one page? Let me see if I can. If I fit on there. Okay, and I know it's doing. Here we go. I like this.
Hey, Professor, should we be, should we get familiar with this website for the exam or no?
I'm not going to have this on the exam. We could do an exam, but it actually is very easy to use. I'll show you in a second. Let's say this. Which is a better way to do this? It probably is. Let me do this. Let me say hide the. Okay, so here's our space that we put it in here. This here. So if you're on this page, go down about I don't know, halfway down or something, and you'll say type your linear programming problem below. That's just another way of saying this. Okay, so I'm going to copy this up there. And just for kicks, let's go ahead and run it and see what happens. You don't have to do this. I'll do it. It'll say no optimal solution exists for this problem. Why? There's no constraints. Okay, so we're going to say subject to. And now we're going to say put these constraints in. That may not work the way I have that in there. My spacing would be a little funny. But wait, I'll show you something really kind of neat about this website, and that's especially for those of you that are taking finance later on. Try to keep these closer. Ooh, I left off something here. This is bad. That should be a Y. This should be a Y. And you should always, and the Y should be the same. If they're capitalized, they should all be capitalized. Okay, I think that's good. So this is the problem we just did. So here's what we're trying to maximize profit. These are the constraints. And I think I'll make this big now. So this is get the most out of these. However, these are the constraints we have. The question is, how many of bear X and bear Y should we make? Oops. That's what we're really asking here is, we want to make the most profit. So how much of these do we sell? how much X and how much Y do we need? All right, so that's what, ooh, okay, that's all right. All right, so that's what we're gonna do. So you hit solve. Oh, there's my first bad one. Solve. Hey. It might not like my spacing. Let me check on top here, make sure my syntax is right. That should work. All right, let's try it again. What the heck? All right. Oh, maybe it likes to do it in a row. I know I didn't have to do this before. Now let's see. Oh, okay. It didn't like there was a space between those. I think you can put them down like this. I think this, and this is probably an easy way to do it. Let me make sure I can do it this way. Get rid of everything. Okay. Yeah. Okay. So this is, I guess it doesn't like spaces. So we can't have a space in there. Small price to pay. Because look what it does for us. It says, look at this is the maximum of P times Y. I'll show you what that is. It's saying that we should make 125 X's and 20 Y's. If that's the way we're going to maximize profit. So this is the optimal solution. And let me stop sharing for a second. No, wait, I don't want to see my face. I want you to just. Oh, I figured out why that thing, my monitor was coming off the thing. That's why I was so sideways looking. Okay, so this is what it had. You notice that we said we wanted to maximize our profit. And it says, okay, the optimal solution is make 125 units of X, oops, and Y equals 20 units. That's going to give us our optimal profit. So 10 times X plus 10 Y. So this is our optimal mix. This is gonna make us the most money. You can say how much money? It'll be $14.50, although that's not the entire amount. We'll talk about that in a second. But going back to the screen. So that's what this is telling us here. The most profit we can make is $14.50. We're gonna make 125 X's and 20 Y's. Now, when you guys go into your finite math class, excuse me, and let me pull up something here. This is a very good tool to use because what's going on here? So this is your first setup. This is just the setup. This is your matrix you'll enter into your calculator. And so here's what this also tells you. This is your first pivot. This is pivot 1. And pivot 1 says, okay, you'll make 137 and a half. Sorry for the poor kid because half of a stuffed cat. And that here's your maximum profit in that one. All right, so this is the most you could make if on the first pivot. This goes to the second pivot. This says, oh, we might be a good idea to make some Y's too. So first pivot, we're making X's. Second pivot, oops. Second pivot, we're also going to make some Y's. And here's what it says. Okay, if you make $20 Y's and 125 X's, X's, make $14.50. And notice that $14.50 is more than $13.75. And then importantly tells you to stop. Are you guys see my screen at all? Oh no. I absolutely apologize, guys. I don't know what happened, but my screen ended. All right. So it just had occurred to me. I didn't save it either. Okay. I may have to do some controls here or something. Well, we won't worry about that right now. Is it recording? It is recording. Okay. Let me ask you something, guys. Could you see me? Or did my screen go blank?
I was able to see you. Yes.
I mean, did my screen just go blank just now, though?
No.
Man, is that odd? It completely went blank. My screen. Okay, I apologize. I don't know. Anyway, this is let's see here. So if you're taking the, if you're doing this in your math class, the beauty of this is if you're doing a problem, it'll tell you what you should get. First of all, it'll tell you what the layout should be for your matrix. And second of all, it'll say what you should get for each pivot, because this will go to the first pivot you're supposed to go to. This one pivots on the X. And then this is the second pivot, and it pivots on the Y. And so there's two pivots there. Now, the beauty of this, too, seeing this using this website, is that if you're doing a problem and you're on pivot 4 and you work it out on here and it does it at pivot 2, you know that you did something wrong. And I can tell you that when I was in grad school, but we were doing optimization, kind of a management thing. But anyway, we would go. We actually had a program that did the same thing with Windows. But anyway, when I was in grad school, you'd use this program, and so you would look at it and say, okay, I'm on pivot 4, and the optimal solution is on pivot 2. I must have done something wrong. So you go back and find it, and sure enough, oh, okay, here it is. So it can actually have you actually check your answer on it, and you can actually do quite a bit with it too. The simplex stuff. Okay, so that is our first optimization. So we're going to keep going, and not on that. Go here, and my spacing got moved up. Okay, so we're going to do the same thing for the happy toaster. Now, this one's going to be a little bit different. We have a little bit different optimization of mounts, because you'll notice that for instance, we make $5 on each X. And truthfully nowadays, I mean, the setup of it is the hard part. The math part, which in the past was far and away the most difficult, that's easy now. And so, if you're looking at these, you say, okay, well, we got toaster X and toaster Y. Oh, I realize what it is. Oh, it shouldn't be on. Oh, okay. I'm sorry. So this is page 2. So we have toaster X and toaster Y, and we're making $5 profit on toaster X and 15 on toaster Y. No, you're looking at these, say, well, let's just make a bunch of toasters Y. We're making more profit on toaster Y. Well, there's a couple problems with that. and the problem is, yeah, it's a lot easier to sell a $15 toaster than it is to sell a $40 toaster. So you may have a constraint that you can only sell so many of toaster Y. There's not that many people who buy that. Whereas you might sell a lot more of toaster X. So it could also be, the demand for them is not always the same. Okay. And we have materials in minutes, similar to what we had in the other one. Let's do this one first. Okay. So we can't just make a bazillion of them because we have these constraints here. Okay, so most materials we can use is that 1,000 feet of materials. And the most we can make for minutes is that. So these are the constraints. Okay, I'm gonna keep this condensed because it's the, just so we can cut and paste it. Okay, so we're gonna maximize. We're making $5 on each X. Plus $15 of each Y. And we have, so that's this up here. And we are subject to constraints. Okay, and the first constraint, this will be for materials. Okay. Yeah, let's write materials. Let's take it out. Okay, so materials we're using 3x plus 10y plus equal to 1,000. And machine minutes. So this is what we're going to maximize our profit, like before. This is subject to, these are the constraints. Now, I got to take these two little headings out here, but let's take this whole thing out, just copy it. Okay, so I'm going to maximize profit subject to these constraints. The constraints rate 6 and 10, 3 and 10. Okay. So that would be what we put in here. And say solve. That should be there. Let's see if this is clear on here. Okay. And so here we solve it, and we should get the maximum optimal solution, $1,575, making 150 X's and 55 Y's. Again, here's the here's the setup. So those, when you're taking your finite class, this is the setup. And if you can enter it like this, it'll give you what the setup is for the matrix. Which, I mean, if you're taking the class, you'll know how to do this, but it's just nice to it's nice just to see it, and then you can put it in. And the first one, the first tableau, they said, okay, just do Y's, 100 Y's. So you thought, well, let's just make Y's. Y's. If you just make Y's, you'll make $1,500 in profit. So, not that that's bad, that's good, but when you add in, if you're looking for the optimal solution, if you make more X's, it's going to be more profitable. It's going to be whatever that is, $75 more profitable. If you make, if you do the mix of, rather than just making 100 Y's, you do 150 X and Y is 55. So that's the optimal. Nope. Okay, now here we're going to start putting these answers in our. There's actually an answer sheet on page 6, I think it is. My spacing got kind of messed up here. And so we'll kind of put these in like as we've gone on. So. Okay, optimal product mix for number 1. You recall that was what's up for number 1? 125? Here's 125 units. Yeah. 20 for Y and 125. Okay. Okay, so this is page 6. So optimal mix X equals 125 units. And this is where it gets a little bit tricky. The optimal income. Now, the optimal income we got looked like this. P equals 1450. However, we need now to look at that. The fixed costs are number one. The fixed costs were 800, and that is not in our equation. Why? Because they're not relevant. But for if you're looking for optimal income, it does exist. So this is sales minus variable cost. Oops. $1450 minus 800 is what? 650? Okay. Yeah, we do the second, same thing for the second one. Copy this down just to save time. X was 150 units, and Y was 55. Oops. Okay, this is page 6. And the fixed costs were $1,000. Oops. Oh, it's already making numbering. Stop doing that. All right, so
Professor, can I see the way you have find the constraints on number 2? Oh, I think it was find the objective function. The way you have you just copy that underneath, correct? Yeah.
yeah, this is like this is I should probably take that.
Okay, because I was a little confused about that, but it's the same information.
Yeah, no, it's
Okay, yeah, I see it now.
okay.
Thank you.
Yeah, so it's a little bit a little bit quirky. They just put it exactly like this, but I mean that's not that big deal. And talk about a time saver. Oh man, especially doing pivots and stuff like that. This is Another thing you can do with a table that is nice, especially for those when you're doing it in class, a lot of times your teacher will have you do it in fractions, and this can do it in fractions. So you can do the pivots and they'll show you what the fractions are. You do I like doing it in decimals in this class just because you know, we don't I'm not worried about the fractions or whether they made the right pivots or anything like that. So you know, but with the but you can do it in fractions. So if your teacher wants to see, you know, the fractions, this website will show it to you. There's a program called Lindo, Lindo, that is actually it used to be based in Chicago. I don't know if they still are anymore, but they were one of the world leaders in making this kind of software. And they could do a lot more complex things than this. Well, let's go ahead and do. Oops. Okay, so these get to be a little bit more complex as you go along. So here we're making coffee. Okay, so each coffee X we're making $5. Coffee Y we're making 10. Coffee Z we're making 15. And again, even though we are looking at the profit, you know, it's misleading to say, oh, let's just make coffee Z, we're making more profit on it. Well, you may not be able to sell as many of coffee Z at $26 as you are of coffee X at 10. So it isn't just pick the highest one. It is, you know, that's why we do the optimization to see which one, what we should be producing. And I mean, and these can be huge. I mean, there's all kinds of companies that have done well because they got this right, and companies that didn't do so well because they didn't. One of the guys I worked with, he got his PhD in economics, and he ended up working for Caterpillar doing logistics. Like, how do you ship? You know, they ship all over the world, these big machines, and finding the most economic, the optimizing, you know, in that case, reducing the cost of getting a machine somewhere. You know, it can be huge. It can be the difference between making a huge profit and a huge loss just on shipping the thing. So, but anyway, they started them out at $95,000 a year, which you say, wow, that's a lot of money. This is like 20 years ago, 22 years ago. So I mean, this is it's very lucrative if you know how to do the optimizations. It's very much desired, and I imagine with shipping nowadays, it's even more desired. Okay, so this is going to be our optimization. So we're going to maximize profit is 5x, 10y, 15z. Well, another thing nowadays is going to sound completely silly, but one of the things about the job that he had that was even better is that it could be done online. Now I know everyone can do a job online nowadays, but back then that was really novel. Someone could actually just work from home and do their job, whereas 99% of the people had to go in. This is like around 1998, maybe 1999, somewhere in there. Okay, now here's the constraints, though. Grinding minutes. Packaging materials. And then, do you want to take a break? You want to take a break for a little bit?
No, I'd rather end earlier.
All right, very good. So these are going to be our constraints. Okay, so I'm going to move this up. And okay, so there's our max. I'm going to take this whole thing. I'm just going to jump right into the constraints. Okay, so grinding minutes is 2x. That's 6y. Z. Yeah, if you want to get up and take a break, that's fine. 4x. We're off next week, by the way. Spring break. Okay, let me check and make sure that I did that right. Okay, now I need the plus or minus. So less than or equal to 9,000. So that's the most we can use of those. $12,000. Okay, so the 9,000, those are the minutes. That's the materials, the 12,000, and ordering minutes. So those are the constraints that they have. This is our maximization function. And so we can copy and paste that into here. I don't know if it does it. Does it keep adding them on? I'm not sure. It might do it completely different. Okay, let's hit solve and see. I think I remember having this one set up that there's actually two optimal solutions. Did anyone get a different solution than this? You can get a different solution. It is possible to get a different solution. The reason being is that it might be that it wouldn't matter, you know. That is, you know, the optimal solution has this for the income. So there might be more than one way to get that income. So there can be two optimal solutions. They'll have the same income, but there'd be two of them, or more, 3, 4, whatever, as long as the optimal income is the same. And if you know that, you know, it is possible that well, you could do a number of things, you know, management things. You could say, okay, we're not going to make, in this case, not going to make any Ys. So don't make any Ys. But if there's more than one solution, you could pick and choose which ones, you know, which is easiest for the production to do. Or it could also be a marketing thing. You know, if there's another optimal solution that has X's, Y's, and Z's, you may want to do it because in the future, maybe the Y's are more profitable. You know, and you don't want to lose that market. So you know, if there's two solutions and one of them has Y's, you may want to keep that in there just to keep the number of hooks in the water. So, you know, in case the Y's take off at some point in the future, you're ready to go. Okay, so 500, so this would look like so X was 500, Y was 0. Thousand units. And the income was 17,500. Oh, I had this pulled up, spring break. What the heck? Founders Day, classes in session. I'm not sure. I'll figure out what that is. It's 8 a.m. to 8 p.m. Okay, that's 12 hours long. Okay, everybody, I want you guys to go to this 12-hour meeting on Saturday on spring break. Take time. Okay, so let's see. This would be 17,500. The fixed cost for number 3 was 10,000. Okay. Now these next two get a little bit tricky. Well, and before I go on to that, you'll notice something that, you know, as you add these on, you know, this matrix gets pretty big pretty quickly. You know, the more constraints you throw in there. they can get bigger and bigger and bigger and bigger and bigger. So, it's not unusual to have these that are absolutely gigantic. It's not unusual for a company or even a small business to have 30 constraints. So you can imagine there'd be 30, But point being, it would be no fun at all to do it by hand. Okay. All right. So 4. Okay, and these are rugs. I don't know much about rugs, but my guess is these maybe were in hundreds or something. Because well, I guess it depends what kind of rugs they are. Okay, so they have the rugs and 2, 2, 3, 1. So A, B, C, D. 2, 2, 2, 3, 2, 2, 3, 1. You might ask, do I have to put that 1D in there? Probably not. 1D and D is the same thing. And we'll do our constraints. I'm going to okay, so here's B. All right, so here are the constraints: feet of packaging, minutes of labor, feet of material, ordering. Okay, so those are, now be careful putting these in. And the biggest mistake people make putting them in is putting the variables in wrong. So we have 2A plus 2A plus 3C, and so be careful when you put them in to put them correctly. And I like to do them separately. That's just me. Wait, I don't want these. What I mean by that is that, oops, is I'll put the the different, for the different types of them, I'll put those in first, and then do the greater than or less than or equal to. You can always copy those down too. All right, let me make sure I got this right. If you, at some point on these, you get, you gotta make sure it's easier to get them right the first time than try to find it. All right, 2D. Okay. So those are the constraints. So we're trying to maximize profit. And these are the constraints. And so we can see what those are going to be. And again, make sure, it's good to look down the columns and make sure that, the first ones are all A's. Second ones are all B's. C, B's. Okay. A, B, C, D. Okay. All right. All right. And so there's the optimal solution. So the optimal solution is we don't make any C's or D's. So 7,000 A's, 4,000 B's, nothing else. So there won't be any rug C or D. 22,000. Fixed cost for that one was 15,000. Was that 7,000? Okay, you can already kind of see this is getting, you know, this is where you start out with in your finite class. These are, by the way, just to give you kind of heads up if you're not, if you haven't had the class yet. These S1, S2, S3, those go along with each of these. And those are there, what they call slack variables, because you might not use all 40,000. So it's sort of like solving for these three or these four. However, there is the possibility that you're not going to use all 40,000. So these slack variables will take away from the 40,000. So they're there. If you use all 40,000, if you use all these, the maximum of all these slack variables will all be zeros. Okay, let's go to number 5. Okay, number 5 is a continuation of 4. Okay, they presented the optimal solution of the marketing manager. Oh, I'm sorry, I read that incorrectly. Who wrote this thing? When presented with the optimal solution, the marketing manager said the mix and problem 4 were was unrealistic. I gotta rewrite this thing. The marketing manager indicated the following maximum demand for each of the following months. Okay, so the marketing manager says, look, you know, we can't sell 7,000 A's. There's not a market for them. We sell 5,000, and B's we sell 2,000. C, so here's what's going to happen. These are just new constraints. So we're going to still have the old constraints. The old constraints aren't going away. Oops. So I'm going to copy this down. So these old constraints, I'm going to take this off. So these are going to stay exactly the same. These subject to constraints. Oops. Learn how to use a computer. Okay, so here's my question. Let's take this first one. So we're going to add that constraint down here. What would that constraint be? So the marketing person, marketing manager says, look, I can't sell 7,000. You know, that's what we got down here. I think 7,000. Look, I can't sell 7,000 rugs, rug A. There's no market for it. You can sell 5,000. So what would the constraint be? Now, these constraints will still be intact. Just for this one, what would the constraint be?
Like the equation,
Yeah.
would it be what 5A plus 2B? I mean, don't I just use the like? I thought I would use like. Wait, I'm confused. I thought
Okay, let's just concentrate on this one, just the very first one. So there is no B, C, or D. So rug A, here's the constraint on rug A. It can't be more than 5,000. So what would the equation look like? Well, so what would that, so here we have A. So what would the constraint look like? A cannot, we can't sell more than 5,000 A's. So what would it be? I think you're on the right track.
I was just using the first number in all the units, like 5A plus 2B.
Yeah, no, but here's the thing, you know, the constraint of 5,000, it only applies to which rug?
A.
Okay. So when we do this, we'll say, okay, it has to be, it can be less than or equal to 5,000. Again, that constraint is only for A. And not all the constraints will apply to all of the variables necessarily. They may, but they don't have to. So that first one, you know, this is the only constraint on A. And this one will be the constraint on B. So B's cannot be more than wrong way. I did it again. There we go. So B's can't be more than 2,000. You know, and notice that, you know, when we ran this thing before, you know, we said that A's were this much, you know, B's were 4,000 B's and 7,000 A's. Well, the marketing person says, look, you can't do that. I can't sell that many. I'm gonna take out the hints. We don't need any hints here. We know where we're going. Okay, so rug C. And again, the 1,500 units, it only relates to rug C. Nothing wrong with that. There are going to be restraints that are only for, you know, certain variables. 1,500. So these are just additional constraints. And again, not all constraints have to do for all, have to be for all of the things. For instance, if says packaging feed available, you may have a certain buyer that doesn't need any packaging. They'll just come and pick up the rugs without any packaging at all. Well, you know, you could have something like the, you know, for A, this is 0, right? I mean, so it is possible that there are constraints that don't affect all of the variables. So these are the new, comma. Oh, I did the wrong thing there. I'm sorry, that's more like it. So we just add these additional constraints on. And again, it's not unusual to have dozens of constraints. Okay, and so that's what we will paste into our thing over here. And that's going to be a very large matrix. Well, it would be a very large matrix to do by hand that way. Okay, now notice our income went down. Whenever you add a constraint, at best, it wouldn't do anything to the income, right? I mean, if the constraint didn't constrain anything, you wouldn't do anything. But if it does change, it's going to reduce the income, just because it the income won't go up with more constraints. If anything, it'll go down. And look at that matrix. There's a fun one. And get that onto one line. So here's the thing. They got the slack variable for each constraint. There's 8 constraints. So there's 8 slack variables. And then this is the profit. And so that would be a, what is it? 13 by 8. So 13 by 8 matrix. That would be fun. It was 13 times 8. I don't know. It's a lot. 24 there, 100, 114. All right. So every pivot, 114. All right. So this is these you can add on the constraints, and down here, hopefully you won't have a teacher that does something like this to you. Yeah. 8 by 13 matrix, and there's 5 pivots on it. So this would have taken you hours if you're doing it by hand. So the website can really save you time. Okay, so this is the actual solution. And again, the income went down because we have more constraints. And at best, if the constraint didn't do anything, our income would have stayed at, what was it, 22,000? Our income would have stayed at that. But because some of these constraints came into play, and you kind of see the ones that come into play, A and B came into play there. Look, we can make 5,000 A, 2,000 B. Okay, 1,500 C and only 800 D. So this is really the optimal solution. Because the first one was not right, you couldn't have done it. So 5, 3, 2. No, 5, 2, 15. Oh, wait, that should be 4,000. Okay. And some of these other ones, you say, oh, those are less profitable, but they're still profitable. They're still adding to the income. It's not as much, but it's still adding to the income. So 19, 300. So the real optimal income for that one would be 4,300. So this one is not obtainable because you can't sell that many of those. So okay, well, what is obtainable? This would be obtainable. So yeah, and again, it wouldn't be a bad idea for you to bookmark that or keep this website, especially if you have not taken the finite math, because this is this really helps out a lot. Oh, and by the way, we say one more thing. If you're wondering why they call it linear programming, they call it linear programming because these are all lines. These are all lines. And a lot of times you'll have things that are lines, you know, that would be for restraints. Now, economists will tell us that restraints don't always go in straight lines. And there is something called nonlinear programming. So they call this linear programming because these are straight lines. It is possible that they aren't straight lines. It's more complex, obviously, but you may have a constraint that looks like that. You may have a constraint that looks like this. You may have a constraint that looks like this. You know, it is possible that there are nonlinear. But a lot of it is linear programming. And again, it just means that there's lines. And the nice thing about that is that, you know, you can establish how to solve them, you know, with lines easier than this. There's some programs that can do that, but it's easier. And a lot of times the complex problems, they will try to make them, you know, even if you have something that looks like, well, this is kind of crazy, but a lot of times, even if they're not linear, if the slope really goes like this, you know, you may try to make that into a line just so you can do the calculations. So linear programming just means there's lines. That's all it is. And yeah. So when it comes to managerial stuff, especially, I know some of these are management majors. The people that do this and do it well, it's pretty big dollars. And they optimize all kinds of things. If you run a store, how many people should you have in the store? Yeah, if you're paying an employee, you know, $600 a month or whatever, or a week, you know, if you have an extra employee on the floor, that can just kill your profits. You know, one extra employee is, you know, crazy. But not having enough employees is crazy too, because then you won't be able to function, or you'll lose sales or whatever. So things like staffing and that, huge amount of optimization going into that. And we get into larger companies, they'll have it more down. They'll have it, you know, they'll tell you how many people to have on this shift, that shift, and all that kind of stuff. And there's all kinds of constraints for having workers. Say, you know, they have to come in. You can't have someone come in for 15 minutes. You might run the optimization and say, oh, well, you know, have Fred come in for 15 minutes. Well, Fred's not going to come in for 15 minutes. You know, so you have to, you know, okay, well, there's a constraint here that if Fred comes in, we have to pay him for at least 4 hours or whatever it is. So they give all these constraints, and, you know, number of employees. Employees can't work more than 40 hours a week, or they can't work, you know, there's all kinds of rules around like staffing and things like that. And that's where these optimizations come in. And just in part, I'm going to tell you that there was I saw an article on a guy that he's in the Chicago area, and he was doing this linear programming. He was doing optimizations for people for just staffing. Just how many employees should you have? And you bill out, you know, he billed out over 20 million a year. He had a lot of clients. You go, oh, okay, well, that's what you billed out, but how much profit do you make? He only had 4 employees. So this is 20 years ago. So even, you know, even if you paid those people 100,000 a year, if you're billing out 20 million, and, you know, what does it run on? A few computers. It's very lucrative. It's very lucrative to do it, but at the same time, someone, you know, his clients probably didn't mind paying $5,000. It was going to save them, you know, $8,000 a month. Well, you know, you add it up. You know, if you're going to save $8,000 a month, you definitely pay the $5,000 to, you know, as a one-time thing or whatever to. It's got to optimize it. So anyway, it's very lucrative to do these, and they're also very interesting. Virtually all your mail routes are going to be done using something similar to this. All of your UPS routes, all your delivery routes are all, you know, using optimizations. This is a huge thing, and it's going to get getting bigger and bigger and bigger. So anyway, if you're interested, if this kind of stuff interests you, it may not be a bad thing to go into. This would be in operations management, and these are called optimizations usually. And they're usually for maximizing profit, reducing costs, possibly reducing time, say with deliveries and things like that. But it's actually a huge field. It was always difficult to find large companies that don't have a lot of this going on. Okay, well, I'm gonna make a drop for that in the on the website, and I think I'm just gonna leave it at that. Nothing for the next 2 weeks. You guys can
Yay.
enjoy your time off. Have a spring break like you're supposed to have. No one's told me here when I was at Robert Morris, I'll say, well, you have something for them to do, and why give them the time off? They're just over winter break. Give them something to do. Make sure they have something to do every day. Oh, that's not really a break. So anyway, so I'll see you guys in 2 weeks, and I will put a drop for this right now in Blackboard. Any question on this? Okay.
Nope.
All right, guys. Well, I will talk to you guys later, and I'll see you in 2 weeks.
Have a good night, Professor. Have a good week.
Hey, Professor, I have a question for you.
Yeah.
Are you going to be teaching, I think it's Principles of Accounting 330 next semester? Because I saw that you taught it before.
Auditing, yeah. I don't. I think you sent me an email, didn't you?
Yes.
Yeah. Let me look.
Because I was going to register. I was looking for the classes for next semester.
Yeah.
And I saw that you taught it before, and I would have liked to take it with you, but
Yeah.
I didn't see your name for next semester.
Yeah. Let me. So no, is that in the? Are you talking about in the fall? Or in
Yes, the
summer?
fall.
Okay.
No, for the fall.
Yeah. Let me take a look and see. Yeah, let me email you back because I'm.
Okay.
But I'll do it right now, and then I'll take a look. I don't think they did, but they may have. So let me. Oh, I know. I can look. I can look right now. I know how to do it. It look like this. If I go to. Okay, if we go to what weird's happening here? Huh. I don't know. This is very strange. Okay, well, let me open up a new window and see what happens. Okay, fall.
No, that's summer 2021.
Yeah, no, it's so down here. Wait, spring 2021? Fall, oh, that's 2020.
Yeah, I have no.
They don't have it up?
No.
Huh. Okay. Well, yeah, let me look it up right now, and I'll get back to you on it. And two, the only thing I can tell you also is the assignments might change. Yeah, just so you know. So if I'm not teaching it, there's still a chance I maybe.
Okay.
So I like teaching it. At 3:30 is the auditing class. Yeah. So anyway, yeah. Let me take a look. I'll look at it right now and give you an email.
Okay, that'd be great.
All right.
Thank you. Have a good one.
I will. Thank you.